Okay, so this is our second lecture, and in our previous lecture, we did up to successive ionization energies and shells. Okay, so we will start from this. So up to this one, you're not having any doubt. Okay.
Yeah.
Okay, fine then. So just okay. Yeah. Okay. Now we will study about successive ionization energies and shells. Now, successive ionization energy provide important evidence for different electron energy levels in an atom. For example, in this figure 2 shows a graph of successive energies of fluorine. Now, fluorine is having 7 electrons in the last shell. Okay, so 7. Yeah, fluorine is electronic configuration is, so fluorine is having total 9 electrons. 9 electron means 2 and 7. 2 electron in the first shell and 7 electron in the last shell. Okay, now 7 electron, now there are 7 electrons from the second shell and the furthermost from the nucleus. So this second shell is the outermost shell and which is at the furthermost point from the nucleus. Now we need to remove these electrons one by one. So if you remove first electron, then the energy is known as first ionization energy. If you remove second electron, that is known as second ionization. Third ionization energy, fourth ionization, fifth ionization, sixth ionization, seventh ionization, and then eighth. Okay, eighth, and then the ninth one. Okay.
Yeah.
So, ninth one means that all the electrons have been removed from the shell. Okay.
Yeah.
Now, if you see, if I am removing first electron, that is from the outermost shell, so first energy and second energy, they are almost similar because there is no change. Okay, they are almost similar, little bit of differences there. But in third ionization energy, it means we are removing electron from F minus 2. Okay, F minus 2. F minus 2 means, okay, let me show you through PPT. Just wait. Yeah. Okay. Now, yeah, this has been shared with you.
Yeah.
Chlorine, atomic number is 9.
Yeah.
Electronic configuration is 1s2, 2s2, 2p, what? 5?
Yeah.
Or what we can say, just 2 and 7. Okay. Now, this is your nucleus. First shell, second shell. 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay. Now, if I draw a graph that is ionization number and energy. This is the energy in kilojoule. So 0 for first one, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay. Now I am removing this electron. So it will be a little bit like this. Second electron is removed. Now F, first case F will become F negative plus electron. It gives you delta H I 1. Okay, then it is F negative plus E, sorry, F negative minus 2. This is F negative converts into F minus 2 plus electron. So we will get delta Hi 2. Third
Yeah.
is F minus 2. We'll get F minus 3 plus electron, that is delta Hi 3. So this is first, second, third, okay?
Yeah.
And in case of fourth, that is F minus 4 will give you F minus, sorry, it is minus 3. It will give you minus 4 plus electron. That will become your delta Hi 4. So first electron, second electron. So this is third electron and fourth electron is removed. So it will be a little bit higher than this one. Now fifth is removed. It will be a little bit more higher. Sixth one is removed. It will be a little bit more higher. Okay. Seventh one is removed. It will be a little bit more higher. So it will a little bit
Yeah.
increase like that. Okay.
Yeah.
Now, if I say I'm writing the seventh one, so it will be F minus 6 will give you F minus 7 plus electron plus delta Hi 7. Okay. Now, in that case, what has happened? All these 7 electrons are removed.
Yeah.
Now, we are moving to n is equal to 1. That is the first shell to remove electron. Now, if you see, this first shell is more closer to nucleus. So that's why it has more force of attraction.
Yeah.
What we can say after removing 7 electrons from n is equal to 2, now electrons are removed from n is equal to 1, which has more force of attraction. FOA means force of attraction, then n is equal to 2. So it will shoot up drastically.
Yeah.
And hence this is the first remove, and if the ninth one is removed, then it will again drastically shoot up. Okay.
Yeah.
So all these energies are known as successive
Ionization energy.
ionization energies. I hope that point is clear.
Yeah.
Okay. Got it? Any doubt?
Yeah. No.
Now let's move to your book. Yeah. Now, what it is saying, the large increase between the 7th and the 8th ionization energy suggests that 8th electron must be removed from a different shell. This large gap is because of change of number of shells,
Yeah.
which is more closer to the nucleus. And that's why it has less shielding.
Yeah.
Okay, more closer to the nucleus with less shielding. So the first shell, that is n is equal to 1, is closer to the nucleus, contains 2 electrons, and the second shell, that is n is equal to 2, the outer shell contains 7 electrons. Okay, so that part is clear, successive energy. Now,
Yeah.
what prediction we can have from these successive ionization energies? Now, successive ionization energies allow prediction to be made about the first point, number of electrons in the outermost shell. Now, if you see this diagram, what we can predict that these are slightly increasing. There is not a steep increment is there. Okay.
Yeah.
Actually, it is something like this, not that one. It is something like this. Okay. So this little bit of increment is there. Now, if you see up to this point, there is sudden more increment, which means that these electrons are the part of one shell. These electrons are part of one shell, and hence we call this as a valence shell, because we know that first of all, the electrons from the valence shells will be removed than that of the other shell. Okay. So
Yeah.
in this way, we can predict that in this case of fluorine, we can predict that in this element, in this element, number of valence shell electron is 7. Here, got it? Yes or no?
Yeah.
Okay. So the first is the number of electrons in the outermost shell. Now the group of the element in the periodic table. Now group of the element, how we can predict the group? Can you tell me how we can predict the group? Again,
Is it
yes.
is it like the number of
Yes, number of valence shell plus 10.
yeah.
Okay, so that is because it is in the p block element. Okay, so
Yeah.
we can also predict the group of element, and we can identify your element also. So the ionization energy shown in table 1, in this table 1, yep, shown in table 1, this table. So the ionization energy shown in table 1 steadily increases, but then there is an increase between the third and the fourth ionization. Now this is again, suppose this is of element X. Now if you see first ionization energy, the first ionization energy is 578 kilojoule per mole. Second ionization energy is 1817. Third ionization energy is 2245. It's 2745. Yes, 2745. Third ionization energy is 11,000 something. Okay. Fifth is 14,000 something, and sixth one is 18,000 something. Now from that part, what you conclude?
That there's a big jump between third and fourth.
Yeah, there is a huge jump between third and fourth. It means these 3 electrons are of the valence part.
Yeah.
And the rest one is of not the valence part. Okay.
Yeah.
So the ionization energy shown in table 1 steadily increases, but there is an increment between the third and the fourth ionization energy. This shows that fourth electron is being removed from the inner shell. That is, in that case, the outermost shell will contain only 3 electrons, and that fourth electron is moved, or it has been removed from the inner shell. Okay.
Yeah.
Okay. Therefore, there are 3 electrons in the outermost shell. The element must be in group 3 since it is in period 3. Now, as third one is removed, it is in period 3. Okay, 3 electrons are there, it is in period 3. So we can say that it is in group 13. Got it?
Wait, can you repeat the group and the period?
Okay, okay. As we have removed 3 electrons from the outermost shell, therefore there are 3 electrons in the outermost shell, and the element must be in group 13. So as 3 electrons are removed, it means element must be in group 13.
Yeah.
Okay, because in this case we have 1, 2, 3, 6 energy, and that is also very high. It can be more. So this is 2, 8, and 3. So 2, 8, 3 means third period. Number of shells will give you period part. Okay.
Yeah.
Okay. So 2, 8, 3. 2, 8, 3. 3 shells are there. It means the period is 3. Now group will become 13. Got it? So element is aluminium. So hence we find the group and we identify the aluminium also just by looking into the ionization energy.
Yeah.
Got it?
Yeah.
Okay, fine. Now suppose if it is a case of a magnesium, then whatever the jump we can see in fourth and the third and the fourth, that part we will observe in second and the third if it is a case of magnesium. Because magnesium is group. Is that clear? Magnesium is having 12 atomic number.
Yeah.
Okay. Yep. Okay, fine then. Okay, now trends in the first ionization energy. Now periodic trends in the first ionization energy provide important evidence for the existence of shell and subshell. Now, okay, you know what is subshell and shell?
So you've learned subshells before. Are they like the regions of the shell?
Subshell is, you can say it is a subdivision of the shell. Okay. So in
Yeah.
first shell, we have only one subshell is there, that is S. Then in second shell, we have two S and P. Then in third, we have SPD, then SPDF. There are different shells are there as a number of shells, and different subshells are there as a number of shell increases. Okay.
Yeah.
Okay. Now we'll see figure number 3. This is figure 3. Now in figure 3 shows the different ionization energies of first 20 elements in the periodic table, and there are two key patterns. Now if you see the general increase in the ionization energy across the each period from hydrogen, helium, lithium to neon, and then sodium to argon. Now see, now first 20 elements. Now we will see first 20 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, and then dip down is there, then again increment, and again dip down, and then again zigzag thing is there.
Yeah.
Okay. Now we will study why this happens. So this hydrogen and lithium, hydrogen and helium, hydrogen is the first element, helium is in the 18th group. Okay. Here, now hydrogen, atomic number is 1.
Yeah.
Electron can be removed. It will have some sort of ionization energy. Okay.
Yeah.
Now, in case of helium, atomic number is 2.
Yeah.
Outermost shell is fully filled. Fully filled atomic shell or fully filled outermost shell is little bit more stable in nature.
Yeah.
It will be difficult to remove electron from that. So ionization energy will be high.
Yeah.
Is that clear?
Yeah.
Okay. Now lithium. Lithium is the third electron. Third
Yeah.
element. Okay.
Yeah.
Atomic number is 2, 1.
Mm-hmm.
It means one electron
There
is there in
remains
the
one in
electron
the
is in the
outer shell.
outermost shell. It can be
Yeah.
easily removed.
Yeah.
Okay. Now wait, I will write it down there. Just give me a second. Okay. So this is hydrogen, then helium, lithium. 1, 2, 3. What is that we have? Beryllium. If you see this one, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Okay. So
Yeah.
do you know? Yep. Beryllium. Then
Boron.
boron, carbon, nitrogen. Okay, fine. Boron, carbon, nitrogen, and then oxygen, chlorine, and then what we have? After fluorine, what we have? Neon,
Yeah.
then sodium, magnesium. Okay, this
Yeah.
is 1s1, 1s2, 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, now 1s2, 2s2, 2p2, this is 2p3, this is 2p4, this is 2p5, this is 2p6, this is 2p6, 3s1, this is 2p6, 3s2. Okay.
Yeah.
Okay. Now, if you see this ionization energy, hydrogen, fine. Then more ionization energy will be of helium here.
Yeah.
Now, if I say ionization energy, and then this one is the atomic number. Suppose this is emission energy of hydrogen, and helium will be more because helium is fully filled.
Yeah.
Electronic configuration. Clear?
Yeah.
Then lithium. Lithium can be easily removed, so it will dip down, but it will not dip down. See, it will dip down to this, less than hydrogen. Clear?
Yeah.
Dip down to somewhere. Lithium. Now, after lithium, if you see beryllium, this 2s2, 2s2 is S. S subshell is again fully filled.
Yeah.
Fully filled.
Yes.
So it will be a little bit more stronger. It will be like this.
Yeah.
Beryllium. Then again, if you see this, what happens? Boron will again drop down. Why it will drop down?
Because
Because
it
of,
has
yes,
it
because of,
has like it doesn't have a full outer shell.
yes, it will drop down because in P subshell it can be easily removed. This will be
Yeah.
like this, boron. And then 1s2, 2s2, 2p2. Now in this case, more electrons are there. So it will increase carbon. Fine. It will increase. Carbon is increased.
Yeah.
Now in case of nitrogen, 2p3. 2p3 is half filled. 2p3 is half filled or not?
Yeah.
In case of 2p3 is half filled, so it means it is more strong. It will be difficult to remove electron, so it will further increase.
Yeah.
This one is nitrogen. Now oxygen part. Now oxygen part again, atomic size is little bit down, so it will decrease like this.
Yeah.
Sorry, it will decrease a little bit, and then it will move up.
Yeah.
Now it will little bit decrease for oxygen. Now fluorine. Fluorine is 2p5. Now electron unnecessary energy. It will be difficult to remove electron or easy to remove electron from fluorine.
2p5.
It will be difficult because because fluorine has a tendency to gain electrons. Okay, because fluorine has a tendency to gain electrons, so it will be difficult to remove. Now, if it is difficult to remove, it will increase. Fine.
Yeah.
Then, if you see neon, neon is fully filled.
Yeah.
Fully filled, and this fluorine size is also small. Small size means more energy, emission energy. It will further increase this neon. Okay.
Yeah.
This trend is clear. Any doubt? Okay, now again, this sodium 2p6 3s1. It will move down somewhere there. It will again decrease. Clear?
Yeah.
Why it will decrease? Because it is now in third shell. As the number of shell increases, distance increase. Distance increase means it is easy to remove. In this case, we are moving electron from n is equal to 3. So in case of sodium, okay, now see, sodium 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is 281. This is 282, 283.
Yeah.
1s2, 2s2, 2p6, 3s1. This will be 3p6, 3s2, 2p6, 3s2, 3p, 1, okay,
Yeah.
2p6, 3s2, 3p2, 3s2, 3p3. This one is 14, 15, 16 is 3s2, 3p4, 3s2, 3p5, 3s2, 3p6.
Yeah.
This is 3s2, 3p6, 4s1, and this is 3p6, 4s2. Clear?
Yeah. Yeah.
Okay. And if you see in periodic table, this is sodium, then magnesium, and this one is aluminium, okay, silicon, phosphorus, and then sulfur, and then chlorine, and this one is argon, okay, and then we have potassium, and then calcium. So this is the one. Now, if we are moving from left to right, this is left to right.
Yeah.
Atomic size decreases, and hence ionization energy increases. Remember
Yeah.
that pattern?
Yeah.
From top to bottom also the same thing. Now in this case, electrons are removed from 3s1, so less ionization energy. So I'm again writing this ionization for atomic number. This is
Yeah. Atomic
atomic
number.
number, and this is ionization energy. So sodium will be 0. Then from there to sodium to magnesium, atomic size decreases, means more force
Yeah.
of attraction. Now more force of attraction means more ionization energy. It will increase like this. Okay.
Yeah.
Now again aluminium 3p1, 4s2, then again 3p1, it will increase. Then 3p3, it will increase. 3p4, it will further increase. It will increase. Fine.
Yeah.
So you will get that trend. Sodium, magnesium. Magnesium is aluminium, then increase. Phosphorus and sulfur is almost same. Okay. Phosphorus and sulfur is almost same. And then again increment up to argon. Up to argon, because they are noble gas, they are not going to lose electron. And then suddenly fourth shell. In case of potassium, we move to fourth shell.
Yeah.
Now this one is magnesium. After magnesium, we have little bit. Sorry, I write it a little bit wrong there. If you see this part, this is little bit this side, aluminium, and then again increment is there. Okay. Now up to this one, increment is there. Up to this. Now in this case, electron is removed from n is equal to 4. So again, there is a decrement. Clear? No?
It's a
Why decreasing?
Oh, okay, yeah. Yeah.
I will explain you quickly. 1, 2, 3. Third electron removed. Now fourth shell. The fourth shell means size is increased. Atomic size increases. So ionization energy decreases. Clear?
Yeah. Yeah.
Okay. So now the electron is removed from this one. So there's a little bit decrement is there. In case this is 4s2 fully filled, so a little bit of increment is there. Okay.
Yeah.
So then suddenly it will decrease and then increase. Got it? Any doubt?
Yeah. No.
Okay. Fine.
Yeah.
Okay. So this is the trend for period 2 and period 3.
Okay.
Okay, so this is the first ionization energy trend down the group. Now in table 2
Okay.
explains the decrease in the first ionization energy down the group. First ionization energy decreases down the group in the periodic table for some same reasons. Although the nuclear charge increases, its effect is outweighed by the increased radius and to a lesser extent the increased shielding. Now what happens? If you see this pattern, wait. Now see, did the increase in the charge, nuclear charge, 11, 12, 13, 14, 15, 16, number of proton is increasing. It means
Yeah.
on the nucleus, the number of positive particle is increasing. So it should provide more force of attraction.
Yeah.
But this nuclear charge is outweighed by the increase in this case from 18 to 19. This increment in charge is outweighed by the increment of the shell.
Yeah.
Now, as the shell increases, the atomic size increases and hence the ionization energy will decrease. So although the nuclear charge increases, its effect is outweighed by the increase in the radius and
Yeah.
to a lesser extent, the increased shielding effect. To a lesser extent, now there are 3 shells which are shielding the force of attraction on the 4th shell electrons. Okay.
Yeah.
So that's why there is a little bit of decrement in ionization energy, or we can say that electron is easily removed.
Yeah.
Okay. Okay. Got it? Any doubt?
No.
Okay, Ji. Now see trend in the first ionization energy down the group. Helium, atomic radius is small, number of inner shell is 0. So atomic radius increases. If we move down the group, more inner shell, so shielding effect is increasing. As the number of inner shell is increased, so there will be increment in the shielding effect.
Yeah.
Now, nuclear attraction on the outermost shell decreases. As the shielding effect is increasing, nuclear attraction on the outermost shell, that is the force of attraction between the nucleus and the electron in the outermost shell, will decrease. And in this way, ionization energy will decrease. The electrons can be easily removed. So we require less amount of ionization energy to move from the element or the outermost shell. Okay. Clear?
Yeah.
Any doubt?
No.
Okay, Ji. So this is the down the group thing. Now,
Yeah.
so we studied all these things trend in the first ionization energy. Okay. Now, trend in the first ionization energy across a period. Across a period from left to right. That also we have covered. Fine. Now,
Yeah.
lithium to neon. If you see lithium to neon, nuclear charge is increasing, plus 3, plus 5, plus 6, plus 7, plus 8, plus 9, plus 10. Fine.
Yeah.
Nuclear charge increasing, but that increment is in the same shell. You see number of shell is 2, 2, 2, 2, 2, 2, 2. Fine. Now
Yeah.
suppose if you are, suppose you have a couch in your home.
Yeah.
Suppose you are sitting alone. Fine. Now your sister comes there. Your father also came on same couch. Your mother also came on same couch. Your friend will
Yeah.
also came on same couch. What will happen? Your movement will be restricted.
Yeah.
It will be a little bit crowding. It means the persons are added in the same couch. It means the
Yeah.
electrons are added in the same shell. So they will become little bit close to each other.
Yeah.
It means the same shell, similar shielding is there, and the force of attraction will increase
Yeah.
as their distance from nucleus is not increasing. I will show you. If you see from, now 2 electrons, lithium, this thing lithium, third electron, fourth, fifth, sixth, 7th, 8th. All the electrons are added in the same shell.
Yeah.
Okay. So what will happen? The force of attraction, this distance is not increasing. This distance is not increasing. Only addition of nucleus negative charge is there. And in here, there is a addition of positive charge. Now, addition of positive charge is at one place. Positive
Yeah.
charge particle is added at one place. So it will increase the density. It will increase the positive charge at one point, and hence also negative charge is increased in this point. Negative charge is increased here.
Yeah.
So force of attraction also increases, and hence there is a decrease in atomic size.
Yeah.
Now we all know that as the atomic size decreases, as the atomic size decreases, ionization energy increases. So we require more amount of energy to remove electron, and hence
Yeah.
we can say ionization energy increases.
Yeah.
Here, got
Yeah.
it? Any
Yeah.
doubt?
No.
Okay, so that is what is covered in this one. Okay.
Yeah.
Now, subshell trend in the first ionization energy. How it is related to the subshell? Although the first ionization energy shows a general increase across both period 2 and period 3,
Yeah.
it does fall in two places in each period. The drop occurs at the same position in each period. Now, if you see, okay, wait. Now, if you see this thing, the same pattern, zigzag pattern is almost same.
Yeah.
After this one, decrement. After this one, decrement. First increase, then decrease, and then increase, then increase. Then almost similar. Nitrogen, oxygen is almost similar. Phosphorus, this one is almost similar. So the
Yeah.
pattern is almost same.
Yeah.
Why? Now see this. That is the beauty of this nature. Okay. Now see, although the first ionization energy shows a general increase across both period 2 and 3, it does fall in two places in each period. The drop occurs at same position in each period, suggesting that there might be a periodic cause. If the change is there at same place, it means it is periodic in nature. That's why we have periodic table now. It means that every change is periodic. The reason is linked to the existence of subshell and their energies and how orbitals fill with electron. Okay, now in this case, carbon to nitrogen, this nitrogen is half filled.
Yeah.
Okay, this is in group. Which group? Second group. Up to this is in period 3. Okay, sorry, this is in period 2, nitrogen, and then period 3, phosphorus. Phosphorus is again NP3 is there. So again, same thing is there.
Yeah.
In both the cases, they have NP3 subshell, half filled subshell is there. Okay. Now across the period 2, the first ionization energy graph, figure 4, shows 3 rise and 2 fall. 1, 2, 3 rise, 1 and 2 fall.
Yeah.
Okay. Now rise from lithium to beryllium. Lithium to beryllium is a common rise because this is 1 electron, 2 electrons are added. So the 2 electron means more force of attraction. More force of attraction means more will be the ionization energy. Okay. The fall of boron followed by the rise to carbon nitrogen. Boron fall, then carbon nitrogen rise, fall of oxygen, followed by the rise of chlorine and neon. This will drop down and then increases there.
Yeah.
So same pattern is also there in period number 3. Is that
Yeah.
clear? Any doubt in
Yeah.
this one?
No.
So now if you see, this is 1s2, this is this lithium is 3, that is 1s2, 2s1. This one is 1s2, 2s2.
Yeah.
This one is 1s2, 2s2, 2p1. So p subshell is there. So electrons are added now in p subshell. So whenever the electron is first added in p subshell, then there is a little bit decrement. Then again, electrons are added in the same subshell. Then up to nitrogen, the electrons are half filled. And half filled means most stable part. Then NP4, a little bit decrement. And then again, same pairing of electron will take place. Up to this point, one electron is added and then pairing will start. Now, as it is paired, little bit of repulsion is there. So decrement is there. Repulsion means electron can be easily removed, and then again pairing will take place. Then it will not be the repulsion part is outweighted. It will not be there, and then hence the ionization energy will increase. Got it?
Yeah.
Any doubt, Manya?
Can you explain the
Okay, wait. I will explain. See.
I know the rise and the falls, but our teacher said that
This
from
repulsion part, what I said.
no, they said that in the periodic table from group 2 to 3, there's like a gap.
No, this is in the group 2 only, beta. This is not in group 3.
Oh.
This is group 2 only, na? Lithium, beryllium, boron, nitrogen, oxygen, carbon. Sorry, nitrogen. This is group 2 only, na?
Yes. Can you explain the graph again, please?
This graph?
Yeah.
Yeah, sure, definitely, no issue. Okay, now, I will again explain this.
Like I understand the rest, but it's just the graph.
Okay, see, lithium is, wait, I will choose red color now. Lithium is 1s2, 2s1.
Yeah.
Now, electron is added in the second shell. Second shell means, is this one. Ionization energy is decreased as the number of shell increase. Ionization energy will decrease. From the helium one, it will now decrease. Okay.
Yeah.
Now, from 3 to 4, electron is added in the same shell, same subshell.
Yeah.
Okay. It is fully filled. Now, if it is fully filled, then it will be difficult to remove electron.
Yeah.
Difficult of removing electron means ionization energy will increase.
Yeah.
Okay, Ji. Now, in the case of fifth, the boron. Now, the electron is added in the p subshell. This is p subshell.
Yeah.
2p. Okay. Now, electron is added in another subshell. So it means this electron can be easily removed.
Yeah.
Then now, when the electron is easily removed, it means ionization energy will decrease.
Yeah.
Okay, Ji. Now, in this case, again, electron is added. Now, in this case, electron is added in the same subshell. Now, as the electron is added in same subshell, what will happen? Atomic size will decrease. Okay?
Yeah. Yeah.
Now, as the atomic size decreases, it means what? Ionization energy will increase.
Yeah.
So, beryllium to carbon. Got it?
Yeah.
Okay. Now, n is equal to 7. Third electron is this one. Okay.
Yeah.
Now, this is half filled. Half filled configuration is more stable. More stability means it will be difficult to remove electron.
Yeah.
So difficult to remove electron means ionization energy will again increase.
Yeah.
Clear?
Yeah.
Okay. Now this is your nitrogen part. Now where you are going to add fourth electron?
Where
This
am I?
side? This,
Yeah.
there. Now in one orbit, first of all, there is unpaired electron. Now as this electron is added, there will be repulsion.
Between which ones?
These two, this one and this one. Wait, I will, yeah. Now this blue electron is added. So there will be repulsion between the blue and the red electron.
Yeah.
Okay, repulsion means less force of attraction.
Yeah.
Less force of attraction means electron can be easily removed.
Yeah.
So ionization energy will decrease. Is that clear?
Yeah, I understand.
Okay. Okay, ji, fine. Now again, one more electron is added. Now electron is added in the same shell.
Yeah.
Now same shell means atomic size will decrease.
Yeah. It would.
If electron is added in the same subshell, atomic size decrease. Now as the atomic size decreases, ionization energy will increase. Okay.
Yeah. Yeah.
So there is an increment there. Okay.
Yeah.
Now if you see this 2p6, it is fully filled.
Yeah.
Now fully filled means more
It
electron
have a.
it cannot be
Yeah.
removed. Electron is fully filled. Atomic size is outermost orbital is finished or completed. So it will be difficult to remove electron. So it will have high ionization energy.
Yeah.
So it will increase like this. Is it now clear?
Yeah. It's clear.
Okay. So same trend you will receive in case of group. Sorry, in period 3 also. This is for the period 2, and same trend you will get in period 3 also.
Yeah.
Got it?
Yeah.
Energy. Any doubt? Is that clear?
Yeah. It's clear.
Okay, ji. Now comparing beryllium and boron part. Beryllium, this part we have already covered. Beryllium and boron.
Are we doing this comparison in this lesson?
Okay, we will not do. Okay. See. Okay, wait. See. We have already covered that comparison.
Yeah.
Okay. If you see this part, this is beryllium and boron.
Yeah.
4 and 5, we have done it. Beryllium energy is more than that of the boron. Why? Because beryllium is fully filled. And in case of boron, electron is added in the one more subshell.
Yeah.
Fine. Which will decrease the force of attraction, and hence electron can be easily removed, and hence ionization energy is less. Okay.
Yeah.
Done.
Yeah.
Comparing nitrogen and oxygen. Again, see this point. Nitrogen and oxygen. This trend. Nitrogen half filled, more stable. In case of oxygen, electron is added, pairing of electron will take place. As the pairing start, repulsion will take place, and repulsion means less force of attraction. Less force of attraction means electron can be easily removed. It means ionization energy is less. Got it?
Yeah.
So that is also covered. Okay. Clear? Same thing is there. Whatever I have told you, the same thing is written there.
Okay.
So your 7.2 is finished.
Yeah.
Okay. So your homework is these 6 questions. Try it. Okay. So tomorrow we will not have class. Okay.
Yeah.
So tomorrow is Thursday.
Yeah.
Okay. So tomorrow, tomorrow means today only, na? Yeah. Only for you, for me. Wait. And today is 13th. Okay. Yep. For you, it's 13th. Na? Yep. So tomorrow, that is on 14th, we are not having any class.
Yeah.
Fine. So we will have class now on Friday.
Okay.
Okay, so Thursday will be off. Friday we will have class then.
Okay.
Okay, so it's clear. Any doubt?
No.
Just
No.
open your cam. Anji.
Just 1 second. It takes time.
No issue, no issue. So just try to do these homework, and you do all these questions on writing part, or what? How you do it?
No.
Hello, just a wait. I need to remove this. Just remove. Yes. Hanji. So how you do it? You will write it in your copy or notebook, or what? How you are going to do these questions?
The questions first. They said that first you have to read through the textbook, which I have, and then
Fine.
write notes first.
Okay, so
Like
notes of this energy I have already provided you. This one single page is enough.
Yeah, so make like revision notes on this, and then do the questions.
So just try to do these questions, 1, 2, 3, 4, whatever you can do. It's up to you. Try to do these questions, and then we will discuss next one. That is 7.3. So this 7.3 is covered in your school or not?
No.
It's not covered?
They're not going to cover it. They said you can do it on your own.
So do your own on the 7.3. Okay, fine. No issue. We will do it. Don't worry. We will try to cover this. The 7.3 is a little bit a bigger one. It will take at least around 2 lectures. Yeah. This one is a little bit big. So this we will do in at least, we will do it. It's not a big deal. It's not that big. Okay.
Yeah.
So okay, fine. And okay,